Thanks for that introduction. So I'm Josh. I am the co-captain and lead programmer on Team Texpand, and I'm going to be doing the presentation for today. So yeah, thanks very much for this opportunity. And otherwise, let's get right into it. My topic today, as you would have seen on the agenda, is I'm going to be doing a custom pathing analysis, or as the slide says here, why should you consider doing custom pathing? Why is it a good option? I think this is a very well talked over topic in the FTC community, and there's lots of different opinions on it. So I wanted to kind of give an overview of everything in terms of what different pathing systems entail, what are the options, and why would some things be a good idea. So with that, I'm going to get right into it. There we go. Okay, so first thing, I just want to say this is not going to be a direct comparison or a direct how-to on how to actually implement these pathing systems or anything like that. We definitely don't have enough time for that. And I'm not going to be looking at metrics in today's presentation. I want to talk through kind of some of the pros and cons between the two and why one could be better than another, but we don't have enough time to dive too deep into it. So it's more of an overview and my thoughts on it. And also just an FYI, this is my opinion on it based on stuff I've done in the past, as well as what I've seen other people talk about and drawn from their experience as well. So just take it with that. Okay, so just before the first thing I want to talk about is just give a quick overview of kind of the definition of the three main auto navigation systems that I want to talk about in this and compare. So the first one here I want to talk about is libraries, so pathing libraries, right? So this is a prepackaged navigation system or way of controlling your robot or moving your robot around on the field in autonomous. This is basically so you don't have to program the actual system. You just have to install it in Android Studio and then tune it. So it's basically to get your robot running, you just are tuning a library or a system, right? You're not building something. So here are some examples of it. You've probably heard of them if you've been in the space at all. We've got Roadrunner, very popular in the FTC community, and we've also got Pedro pathing. It's more recently released, but getting quite popular quite fast. Then the next option, obviously, the subject of this presentation, we've got custom pathing. So this is developing your own solution to auto navigation, not using a library. And with discussions like this is often considered the more advanced or higher performance pathing system. I'm not sure if I agree with that exactly, but we're going to talk more into that in a bit. And so here I just wanted to highlight some kind of concepts that are used in kind of custom pathing and stuff like that. Again, this isn't all of them. I just wanted to give you a feel for what I was kind of talking about when I'm saying custom pathing. So I think custom pathing itself is not actually how you do it or what type of concept you use, but rather the fact that you're implementing it. So here you see I've got pure pursuit. That's like a full algorithm. Some people would consider it a library, but I think it's considered more because you implement it yourself. It's more of a custom pathing implementation. You got a guided vector field, Bezier curve generation to generate the path, stuff like that. I'm talking about it more in a few more slides. And then the last thing in here is a slightly simpler one that's not really pathing, but I think it was worth including. So this is a PID to point. So basically what this is it's a much simpler version of pathing, as it takes out the step of actually generating the path. So it's not really pathing, it's more navigation, right? So it's targeting where you currently are on the field to where you would want to be in a straight line, just using a PID controller, hence the name PID to point. You're targeting a point with a PID controller. This is useful because you can, as you're starting out with auto FTC programming in general, it gives you a good look into the fundamentals of like PID stuff, localization, which becomes useful in pathing in future. So now I want to go into kind of what each option entails. So like, what are the pros and cons of kind of a library, because there's not much to talk about there in terms of your options when implementing it and efficiency and stuff like that. And then also going into custom pathing, the steps in that, and then finishing off with kind of what I think is a good way forward, depending on where you're at as a team, individually, stuff like that. So yeah, let's get into it then. So first, I wanted to highlight some of the pros and cons or pros and cons I think in libraries. Um, so as I was saying, it's a pro of this is it's easy to install and set up, and then once you've set it up, you don't actually have to build anything. Obviously, you're just tuning it, right? And even when you're tuning it, if you encounter errors when modifying certain things, when tuning stuff, there's lots of support for this in the FTC community because most likely someone else has encountered a similar error, right? So they can actually give you the solution without you having to problem solve the solution. So that does help a lot. Um, and because of that, pathing systems are made to be flexible and adaptable, right, to um, different robots and to be able to be used by as many teams as possible. So that sometimes can sacrifice performance. Not always, and it's often with how you tune it, but because someone else has built it, you often don't understand how exactly to tune it, which means that you might not get as much performance as you might if you're doing custom pathing or building a system yourself. And that's why I think the biggest thing right here, and the con I'm going to talk about here, is that I think the biggest thing about custom pathing that's a pro and why I would suggest people do it is because of the fundamental skills you learn while doing it. It's not when using a library, you're not actually learning as many programming skills as you would programming a custom pathing method, right? Like I'm saying here on the slide, you're not learning programming fundamentals, you're just learning how to tune a library. Um, so you're going to learn a lot more when building a custom pathing system. So yeah, now I want to go into kind of custom pathing, the pros, a few steps on what it would be to implement it, and then finish with what makes sense going forward um, for you as your team. So again, this could be any type of pathing implementation. I'm just going to show you some concepts. I think the idea of custom pathing, and as I've realized, as I've explored it a lot more in my FTC journey, it's not so much about what you implement, it's the fact that you're implementing it so that you do get those skills out of it, that you learn more debugging skills, you learn more programming skills, you just learn a lot more skills in general, which then translates a lot into when you encounter error, how do you go around fixing that problem, fixing that error, finding the solution, or just generally improving whatever system you're working with. So then there's 3 steps I want to highlight here with any sort of pathing implementation. And these are the steps that are also used when in a library, right? So this is what I'm saying, right? Custom pathing versus a library, the actual implementation is often the same. So the library implementation will be very similar to this, but it's the fact that you're implementing it again. As you can see, there's quite a common theme here. I keep repeating it, but it's a very important one. So the first step here is localization or tracking your position on the field. This can be through odometry wheels, through cameras and April tags, distance sensors, whatever it is, or the optical odometry sensor now. So again, I've got some examples here of the math involved, but even the math itself is not actually that complex at all. Often it's overcomplicated, but there you can just stick with the most simple methods and it'll be quite easy and simple to get through. Okay. So then the second step of this pathing in general would be the path generation. So now you have your position on the field in your robot, you know where you want to go, but now you need to generate a path to get to that point and the most efficient path or a path to avoid obstacles or anything like that. So you've got a few options. On the right, you've got Bezier curves. These are pretty nice ways of generating a path, but you do need a way of visualizing it since only the end and the start point that you input are actually on the path. The other ones are off, and they determine my vocabulary broke, but it determines how sharp the curve is. Sorry, and then on the left you have splines, which for the most part spline generation uses the points of the spline are all intersected by the path, which makes them much more intuitive when you're generating paths or anything like that, or when you're actually creating the path. And then the last step would actually be, now that you've got the path, it would actually be to follow it, right? So there's a lot here. I don't know if I have time to go through all of it, but I'll go through as much as I can. So you got on the left here, you might see it familiar. It might look familiar. It's actually similar to the Wolfpack implementation if you saw their video on it. But basically what it's doing is it's using a type of guided vector field. And you can see on the right here, there's an example of that. So you can see there's a whole lot of arrows that for any given point in a field, it's going to push the robot to most effectively, the robot or anything actually in this case, but in our case, it's the robot, to get back onto the path and continue following the path. So that's basically what we use in FTC sometimes for following, but often it's not actually a true vector field. As you can see here, they generate points for the entire field, which isn't as necessary for FTC. So for FTC, when we talk about a guided vector field, most of the time we just talk about the target velocity for a given point on the path, not for the whole field. So it's saying, you can see here the blue arrows, it shows at this point on the path, this is the target velocity and direction the robot needs to travel. And then you've also got this red arrow, which is saying this is the corrective power to make sure the robot's getting back onto the path. And this is where PID to point becomes useful, because if you've done one before, it's very similar. You're just adding in other concepts to make it a more effective and robust system, right? So then, now that I've kind of gone through what each of them are, what they entail, and time-wise, what I would suggest, I'm going to finish off on this slide of what does a good path forward look like, in my opinion, from where you're at. So I've created a bit of a table. So we've got current level of your FTC experience, so your rookie, intermediate, advanced, and then what is your goal in FTC? And then at each point when they intersect, this is what I would suggest you would be doing at this point. So you can see here, I've got fame and glory. So if you're just competing in FTC for the bragging rights, you've got gaining STEM skills, having fun, and then so you can see here, right? Most of the thinking behind actually doing custom pathing is the learning experience behind it. If you're in FTC to have fun, play around with robotics, but don't have a hang of a lot of time to put into it, then I would probably suggest using a pathing library, because you don't have to spend as much time understanding everything, but you can still get a pretty good result. Whereas if you're wanting to gain STEM skills or do really well in the competition, I would suggest building up from a PID to point implementation into some sort of pathing, so that you have a more basic understanding and are able to debug, solve issues, and just improve your code in general. And it just gives you a good base to be able to go, okay, now in the code, the rest of the code, I need this functionality, so I can easily just add it in because I have all the code myself and stuff like that. So I hope that kind of was helpful to give you an overview of what everything's happening in the space and what is a good way forward. Actually, yeah. So other than that, that's my presentation over then. So we can open a Q&A if people have any questions on implementation or just the concept in general. Yeah.
Thank you so much. So do we have any in-person attendees that have any questions? I saw one in the chat for online. They said, what skill sets does a team need to start custom pathing? Would you recommend it for a second-year team, or should the team learn Roadrunner first and then go to custom pathing?
Yeah, so actually, Pedro pathing is also a library. It's like an alternative to Roadrunner almost. I personally don't like Roadrunner at all. I wouldn't suggest it. If you are like a second year team, like the question is saying, and you still see yourself being an FTC for a couple of years and you want to do well, then I would suggest looking into custom pathing, doing your own localization, stuff like that. It's just going to take you further in the long run, I think.
Great, thank you. We have another question from the chat. Are there any websites or videos that we can use to find more documentation on custom pathing?
Yeah, so there's not real documentation in terms of step-by-step work through. But I would suggest, like I mentioned in the presentation, looking at Wolfpack's pathing video. That is a very useful resource. And I would also, I know that there's another GitHub repository on GitHub that is called Mercurial FTC. They also have a pathing implementation. Unfortunately, there aren't documentation or step-by-step ways of that show you building the way to build it. But I think that's a big part of actually building the pathing system is you have to figure out through looking at other people's codes, some videos and the concepts and stuff, what the best way through to do it is. So yeah, Wolfpack's video and maybe Mercurial on GitHub.
Great, thank you so much. So in person, do you have any questions? Yes.
So I want to know at what stage, I mean, how many years in do they start exploring the custom pattern? Or how did they get started?
Okay, so we have a question for y'all. How many years, wait, do you wanna just say this one? I have it on easier.
I mean, how much experience do they, have before they start exploring the custom?
Okay, so how much experience did y'all have before you started going and exploring the custom pathing route? Oh, you're muted right now.
Oh wait, sorry.
Okay, you're good.
We actually had very little experience. We did a PID point implementation just before Worlds last year, and we also used Roadrunner slightly before that, but very little. And then we did PID to point last year before Worlds, and then we implemented custom pathing after Worlds last year. So we did auto navigation with encoders before that, but besides that, we haven't got more experience than that.
Okay, we'll take one more question from in person, and then for all the online people, Josh, you can probably just reply to them in the chat and they can get their questions answered. Okay, so yeah.
Did you encounter like computational problems when you were integrating with curve? Because I've heard that with Roadrunner, there was a big issue was that loop times were lower when it determined like cortex lines. So if you had an issue with that, how do you fix that?
Did you catch that?
No, sorry, I didn't quite catch that.
I think you need to go a little louder.
So when you were generating your paths, I've heard that with Roadrunner, the big issue is that loop times may increase because you have to calculate every point on the path individually. Did you have any problems with that? And if you did, how do you mitigate that?
Yeah, so I don't know exactly how Roadrunner works, but I have heard that there is loop time issues. With the kind of pathing that I did, all of the generation of the vectors for the guided vector field are generated in the initialization stage with the pathing of the Bezier curves. And then the only calculations needed for the loop times is actually searching for the closest position to the path based on the robot's current position. So that was done, that plus the PID to push the robot back onto the path. I think the loop time for just that section was about half a millisecond. So yeah, it's very fast compared to other systems.
Okay, great. Thank you so much. Let's give them a round of applause. Thank you so much for presenting.